Okay, so this is going to be 4B and 4C. So what causes inductive noise on ground and supplies? Um, so this could be, we'll make this ground, and this could be another power wire. And so it's kind of in the name induction. Induction is when a wire that has current is going to make some magnetic, it's going to have a magnetic field around it. And the same is true for this. But so the question is specifically asking for what causes inductive noise on grounded supplies. So that would kind of be if there's another wire that's not power or ground, but goes in the vicinity of power or ground. So this could be this blue wire, that's what this is. It could be from something completely different. And say maybe, it goes through a resistor. Yeah, so something like that. This blue wire, if it has current, it's going to induce a magnetic field. And if that magnetic field is in the vicinity of this, if power or ground, even though they have their own current, if power or ground wires are in the vicinity of the magnetic field of this blue line, of this blue wire, then it's going to create noise on power and ground. And we could do this separately, kind of like a form of superposition. If we took away, ground's already zero, but if we took away, we'll think of it in terms of current actually. If there was zero current in ground and zero current in power, whatever this is, VDD, and we just had maybe an AC current coming through here, what's going to happen? We're going to constantly have a magnetic field that is changing. Even though our wire is stationary, the magnetic field's changing, so it's going to induce pretty much, as long as this is alternating, we're going to get some alternating induced current in here. So that's exactly what's going on. But because the ground and power also have current, it's considered noise. So it's ground and power's regular current plus a little bit of induced current, and that induced current is what we call the inductive noise. Okay, now let's go to what is capacitive coupling on signal wires. Okay, so capacitive coupling on signal wires. This is kind of just, we'll go to the transceiver lab. So this is kind of, again, remember like with a capacitor, it wants to pass AC. It wants to pass AC of higher frequency more than lower frequency. But, so here's a transmitter, here's a receiver. This signal right here, this is kind of like a DC, because some of these things take power. The transmitter is going to take power to drive the system, basically. But what we're trying to transmit, the message we're trying to transmit is AC. So this is DC, but it has some AC being piggybacked on it. And that AC is our modulated waveform. On the receiver side, we don't want the DC. All we want is the AC. So it's pretty straightforward. You just hook it up to a capacitor. And if we were to look at it, it's going to come through here. The capacitor is going to block the DC component, but that modulated AC or carrier, both frequencies, if we choose this correctly, it's going to pass them. So then we're left with, we go from this might be like a 5-volt, it might be a sine wave, not a sine wave, it's going to be our modulated our modulated waveform, AM modulation, but it's going to have a DC offset. And over here, it's going to be that same AM modulated signal, but it's going to remove the DC offset. So that's pretty much what a coupling capacitor does.